Hello everyone, welcome to free crash course for competitive exams held by Virat Hindustan Sangam in association with Manifest IAS Bengaluru. This program is inspired by Dr. Subramaniam Swamy and is convened by Shri Ravi Shankar Sir, State Education Convener for VHS Karnataka branch and also President of Good Neighbors India NGO. So I am the chief mentor of your program. So we have dealt with polity, history and economy part and dealing the geography part. So you can watch this program online on the YouTube channel of Virat Hindustan Sangam. So we have provided the link also on the for any further mentoring regarding the any competitive exams. You can contact us via the VHS Education Forum Telegram channel. So we have provided the link for that also as well, right? So we were discussing about the water cycle yesterday. So we were discussing about water. So what is water? How does the water cycle? How does it condensation happen? How does the precipitation happen? How does the evaporation happens? So all these things we have discussed yesterday, and we have mostly spoken about the formation of clouds and various types of clouds and all these things. So now we will discuss the precipitation related things. Precipitation. So what is precipitation? Once the condensation happens, condensation is turning of gaseous water vapor into clouds. So that cloud falling in the form of rain is called as precipitation, right? So it is the release of moisture, whatever the moisture that is condensed from the water vapor, that moisture is released in the form of liquid, in the form of rain or in the form of hailstone or sleet, frost. So all these things. So that is the meaning of the condensation as well as precipitation. Precipitation just means you can say it as rainfall. So rainfall is in liquid form, but when it happens in the solid form, it is called as snowfall. So that is the difference between the rainfall as well as snowfall. So not only rainfall and snowfall, it also happens the precipitation, that is the cloud or the water saved in the atmosphere, comes to the ground in many other forms as well. One is the sleet. One form is called as sleet. What is sleet? It is frozen raindrops. Raindrops coming down directly is in the liquid form is rainfall. Whereas if it comes in the form of ice, frozen raindrops. If the raindrops get frozen and falls to the earth, it is called as sleet, right? Why does the sleet takes place? So why not rainfall? Why there is a requirement for sleet? So sleet is a solid form of precipitation. So the cloud condenses and precipitates in the form of solid, that is called as sleet. So why does the sleet takes place? See, here what happens, there will be a sub-freezing layer. So suppose here cloud is there, right? So here it is warmer. So generally what happens, as we go up, the temperature reduces. At the bottom level, there will be warm temperature. So as we go up, the temperature reduces, right? So, but if at the ground level, if there is a sub-freezing layer, so ground level it is colder and the upper level if it is warmer. So what happens when the rainfall comes, it gets frozen at this layer, because here it is the temperature will be less. So it gets frozen and forms as a tiny droplets of snowfall or tiny droplets of frozen raindrops. Raindrops gets frozen. So this is when does it happen? When the upper layer is warmer and the lower layer is cold, sub-freezing layer, then only this form of sleet takes place, right? Then one more form is hailstone. Hailstones means alikallu. So hailstones, they are small rounded pieces of ice. So they are small rounded pieces of ice which fall onto the earth, right? So when does it will be in the gaseous form. So when the condensation happens of the moisture, so when it falls, when the saturation level is breached, when it falls to the ground, it passes through the cold layers, right? When it passes through the cold layers, it freezes and when the freezing happens, the hailstones will fall on the ground, right? So these are the types of the precipitation. Next we will talk about the types of rainfall. What are the types of rainfall? We have convectional rainfall. Convectional rainfall. What is convectional rainfall? The normal type of rainfall is convectional rainfall. So what happens? The air gets heated. So when the air will be having lot of moisture, and when the air gets heated, it will take up lot of moisture from the lakes, oceans, rivers and all those things, and the light air, it will go up. So light air will, it will not stay at the ground level, it will go to the upper layers of the atmosphere. Once it goes to the upper layers of atmosphere, what happens? It loses the heat because upper layers will be cold. So it loses the heat, and once the heat is lost, what happens? They will form a cumulus clouds. Cumulus clouds will be formed. Cumulus clouds, I have told you yesterday. These type of clouds are cumulus clouds in this shape. Cumulus clouds are formed, and rainfall will takes place, right? So this is the convectional rainfall because of the heating of the air. So this is actually witnessed in the equatorial regions. Equatorial regions, what happens? In the from the morning, the temperature will be very high. So by the afternoon, lot of evaporation will take place. Condensation will the clouds will be formed. Immediately after the 12 p.m. or 1 p.m. Rainfall will start falling. This is the convectional rainfall found in the equatorial region. Next you have the orographic rainfall. So orographic rainfall means what? Orography means mountain. Anything related to mountain is called as orography, right? So suppose here oceans are there. So ocean is there. So once the air is moving over the ocean, what happens? It takes up lot of moisture from the ocean. Once it takes the lot of moisture, what happens? Here it will find a barrier. Once it finds a barrier, the air mass has to climb up the mountain. Once it is climbing up the mountain, what happens? It will see at the sea level, the pressure will be high, right? But as you go up, the pressure will be lower. When the pressure is lower, what happens? Expansion takes place. So high pressure, compression. So as you go up, low pressure, expansion. The air mass gets expanded. So once the air mass gets, not only the air mass gets expanded, here temperature also falls. Once the air descends up the mountain, what happens? Temperature will fall down. Once the temperature falls down, what happens? The condensation will take place, and there will be heavy rainfall on this side of the mountain. So I have told you yesterday itself. So this is the windward side, this is the leeward side. So once it crosses here it will be dry. So this is the leeward side wind. Here there will be no rainfall, right? So this is called as rain shadow area. Leeward side is called as rain shadow area. Okay. Okay. So here once it descends down the hill, the temperature rises. Once the temperature rises, there will be no rain, and this part will be very dry. This part will be wet, and this part will be dry. The best example is the Western Ghats. So Western Ghats, that side towards the Arabian Ocean, it is lot of rainfall, whereas towards the plateau, towards plain, so there is no rainfall. Very less rainfall will be there, right? So this rainfall on the windward side is also called as relief rain. So relief means mountain relief. So mountain relief rainfall, right? Next you have the cyclonic rainfall. So third type of rainfall is cyclonic rainfall. I have discussed the cyclonic rainfall already I have drawn the diagram of the eye. So low pressure area, here it will be high pressure area. This is the eye wall, center part is the eye. So from here cumulonimbus clouds will come out. So cyclonic rainfall I have already discussed. Next we will talk about the world distribution of rainfall. How is the rainfall distributed across the world? So if you look at the rainfall, see at the equator there is too much rainfall, but as you go towards the pole, the rainfall reduces, right? So equator is itself has a lot of rainfall, and so coastal region and ocean region has more of rainfall because there is lot of moisture available from the ocean and the coastal region. So rainfall will be very high on these regions, right? Then also between 45 degree and 65 degree north and south. latitude. So what is 45 degrees? So above the Tropic of Cancer it comes. So Tropic of Cancer 23.5 degree. So above that you have 45 degree north latitude. From 45 degree north latitude to 65 degree north latitude, as well as 45 degree south latitude and 65 degree south latitude. I told there is westerlies. So I told westerlies means what? So they are winds blowing from the western direction. So this because of the westerly. So even in India, in the Punjab region, we will in the October, November, December region, we will find the westerlies. Rainfall because of westerly. These westerlies carries the moisture from the Mediterranean Sea, Atlantic Ocean, and they will bring the rainfall to the foothills of the Himalayas as well as the Delhi, all these regions. So westerlies. So the winds blowing from the west is the westerlies between 45 degree and 65 degree. They will bring the rainfall, right? Then also in the across the world, and also windward direction of the continents, that is where the winds will come and attack the mountains, right? So it may be in the African, in the Australian region. Here there is one mountain range. So here if the wind comes, here there will be windward rainfall. Best example is India's monsoon. So wherever the wind comes and attacks the mountain, there will be rainfall, that is windward rainfall. Okay. So then we will, last topic on this chapter, of this chapter, rainfall and water and oceans. So we will talk about the precipitation regimes. So precipitation, rainfall, how is the rainfall distributed? So we have the highest rainfall. So what do we call as the highest rainfall is when the rainfall is over 200 centimeter. So when the rainfall is measured in centimeter, if it is more than 200, so centimeter means what? So in a small area they will take how much rain will fall in this small area, right? So the more the rain, more the centimeter. So 200 centimeter over the 200 centimeter rainfall we will find in the equatorial region, and also windward slopes of the mountain we will find this to above 200 centimeter. Interior continents, for example, the India's interior, that is central India, Delhi region, or if you take the central China or central Siberia, there you will find 100 to 200 centimeter rainfall. So average rainfall. Then there is in the temperate region. What is temperate region? Between 23 degree and a half and 66 and a half degree. In that region, you will find what? You will find temperate region. In that region, the rainfall will be between 50 to 100 centimeter. So 50 to 100 centimeter, it is below average, and the less than 50 centimeter is called as low rainfall. Low rainfall, you will find it in the rain shadow areas. So where there is no wind to bring the rain. Rain shadows areas you will find and also polar region you will find polar region, there will be no rainfall. There also you will find very less rainfall. Okay, so now this water and oceans is done. We will talk about the world climate and climate change. How is the world climate distributed? What is the concept of climate change? So this world climate, this concept, the division was given by one person called Koyappan. So this Koyappan scheme, there is a differentiation of climate by this Koyappan scheme. So this is the Koyappan scheme, how the entire climate in the world is distributed. So according to this scheme, there is a vegetation distribution. So how the vegetation? So different type of crops, different types of forests, right? Different type of climates, how it is distributed. Based on that, this scheme is formulated. Not only that, based on vegetation, and the second factor is climate. Based on vegetation and climate, this scheme of differentiation is done. In climate, there are two criteria. One is temperature and precipitation. So we will discuss what is this Koyappan scheme. So first there is the first group is Group A. Group A is tropical humid climate. So tropical humid climate means, tropical means what? Within the tropic region, 23 degree and a half north and 23 degree and a half south. In this region is called as tropical region. In that, if there is humid climate, humid means what? There is lot of moisture in the air. So that climate. So that is divided into three regions. One is tropical wet, where there is lot of rainfall. Tropical monsoon, that is India, and tropical wet and dry. So there are certain regions where there is both wet climate as well as dry climate. This is divided into 3 regions. These letter codes are not very important because it is confusing. So it is the letter codes are not very important actually. So this climate is found between Tropic of Cancer and Capricorn. So in this tropical humid climate, this ITCZ, I told you intertropical convergence zone is there. No, it will move only in this zone, in the tropical zone. This ITCZ won't cross the Tropic of Cancer or Tropic of Capricorn. It will move only in that region, and this region is very hot and humid, and also there is high rainfall. In this region there is lot of rainfall because of the convectional rainfall, and temperature range is also low. Means what? So for example, if you take the India's example itself, if you measure the temperature, it is in the summer it will be around 35 degree and in the winter it will be around 25 degree. So the temperature range is just 10 degree. But if you look at some places, there are temperature range in the summer it will be 45 degree, 50 degree. In the winter it will be minus 20 degree. So there is lot of variation. So in the tropical region, the temperature range is also low, right? So first is tropical wet region. So tropical wet type of climate here, in this there is no dry season. There is always rainfall in the tropical wet region. Where do you find the tropical wet region climate? You will find it in the Amazon forest. Where is Amazon forest? In the Brazil region. So you will find the tropical wet climate there, and also you will find it in the tropical evergreen forest. So for evergreen means they don't dry. So that is the first thing. Next is tropical monsoon climate. So monsoonal type of climate, India's climate, it is short dry season. Dry season will be very short. So in India also dry season is this April and May is the dry season. After that we will get the rainfall. So only short dry climate is there. So next is tropical wet and dry climate. Tropical wet and dry climate, here it is wet season is short. Here wet season is short, dry season is longer. So where do we find this tropical wet and dry climate? It is found in the Bolivia and Paraguay. Where is Bolivia and Paraguay? South America. So there you will find this. So what is the type of forest in this? The forest here is a deciduous forest. What is deciduous forest? Deciduous forest means that forest which will shed the leaves during summer. Summer ali elegulu udrute. That is deciduous forest, right? So here in this climate, the dry season, winter you find, winterly there is no rainfall. Winter will be dry season in the tropical wet and dry. Next is, so next type of climate we will talk about is the dry climate. Dry climate is the, code is B. What are the dry climate? So you have 4 types: subtropical steppe, subtropical desert, mid-latitude steppe, mid-latitude desert. So subtropical means what? It is subtropical means it includes the tropical as well as temperate, right? It doesn't include the entire tropical, subtropical. So in this dry climate, by the name itself you can know that there is very less rainfall in this region. And also here, where do you find this? You find it between 15 degree to 60 degree north and south. 15 degree to 60 degree north and 15 degree to 60 degree south, right? So between 15 degree to 30 degree. So between 15 degree to 30 degree. So 15 to 60 is this entire region, this dry climate. But between 15 to 30 degree, that is within the tropic. Within 30 is tropics. So in the subtropical region, you will find the subsidence of air. What do you mean by subsidence? So air is coming down. So air is not rising up, air is coming down. That is why, see, when the air rises up, what happens? Rainfall will take place. When the air comes down, rainfall will not take place. That is why it is dry. Clear? Can you link it? Yes. Okay. So because of it, here what happens? There will be inversion, temperature inversion. I told you, temperature it should reduce as we go up. But since air is coming down, there will be inversion. So at the bottom, the layers will be cold and the upper layer will be warm, right? That is why there will be inversion. So also in the dry climates, there will be cold currents. So I told you what cold currents we will discuss. So currents is, they are the rivers in the ocean. So just like a rivers flow in the on the land. If the river is flowing in the ocean, that is called as current. So even where there is cold, there are two types of current, warm current and cold current. Where the cold current is there you will find the dry climate, right? So there are two types. One is steppe and desert. So steppe means what? The steppe is a transition zone between, see, here you have tropical climate, and here on the other side you have desert. So steppe is in between. It is neither full of rain nor full of desert. It includes the features of both the desert and the tropical region. That is called as steppe. It is a transition zone. So steppe, how do you remember it? It is actually grassland. So wherever there is vast grassland, it is called as steppe. So we have these pampas, like velds, right, prairies. All these are steppe type of climate, right? So in these regions there will be lot of rain, temperature is high, and the range of temperature is also high. First of all, temperature is high. The range, that is maximum temperature and minimum temperature range, is also high. So in the desert region, the rainfall will be very less, right? So next we will talk about the warm temperate type of climate. So these are the climates. So here steppe you will find in the low latitude, that is within 30 degree, semi-arid or dry type of climate. Arid or dry. Arid means very dry type of climate. Desert, if you remember the desert, that is the arid type of climate. So semi-arid means that is steppe. It is neither desert nor rainforest, right? Mid latitude, that is between 30 degree to 60 degree, you have semi-arid and arid. So these are the dry climates. Next we will talk about the warm temperate climate. So in under warm temperate climate, so this is found between the 30 degree and 50 degree. Between 30 degree north to 50 degree north, 30 degree south to 50 degree south is the warm temperate. So it is found both on the eastern and western margin. So if you take any continents, they have eastern boundary and western boundary, right? So you have, if you take the American continent, you have east coast and west coast. In the east coast is bounded by Pacific Ocean. West coast is bounded by Pacific Ocean. East coast by Atlantic Ocean. So every continent has east coast and west coast. So this warm temperate climate you will find on the eastern margin and the western margin of the continents. So here what happens? So you have a warm summer and wild winter. So summers will be very hot and winters will be very mild. That is neither too cold nor too warm. So here what are the types of climate you have? You have humid subtropical. Humid subtropical climate. So it means what? Summer will be warm and there is no dry season. Summer warm irute, but dry season won't be there. This and all you cannot remember, but this you should remember. So humid subtropical. In this what happens? So where do you find this humid subtropical climate? In the North India. Above the Tropic of Cancer, you find the humid subtropical climate. Not only that, you find it in the South China. Humid subtropical climate is found in the South China region. Also, humid subtropical, you will find on the eastern margin of the continents. Eastern margin, so US East Coast, New York side. There you will find East China, that is near Beijing coast, East Coast, South China Sea, East China Sea. There you will find the humid subtropical climate. Next you have the Mediterranean climate. You know the Mediterranean Sea, right? So this is found between the 30 degree to 40 degree latitudes, both in the north and southern direction, southern hemisphere. So this is actually found in the Mediterranean climate, is actually found in the west coast only, not on the east coast, right? So where do you find this Mediterranean? First is the Mediterranean Sea. Next is you will find it in the Californian region. You will find it in the Chile region. Where is Chile? South America. Then you will also find it in the Australian region, right? So there you will find the Mediterranean climate. So what is the influence over the Mediterranean climate? See, Mediterranean climate is very important from your exam perspective. What is the importance? Means, see, Mediterranean climate only there will be subtropical high influence. What is subtropical high? Where the air will be descending. So tropical low, that is equatorial low, means air is going up at 30 degree. 30 degrees subtropical. There air will be descending down. So that will be influencing the Mediterranean climate in the summer. So when there is air is coming down, there will be no rainfall in the summer time. Next, westerly. Westerly will also be influencing. I told you from the Mediterranean, westerly will come. So westerlies will have an impact in the winter region. So during the summer region, the subtropical high. During the winter region, you will be having westerly. So why does it change? Why does it change? See, this is Earth, this is equator. So this is between 30 degree to 40 degree is the Mediterranean Sea. So Mediterranean climate. So what happens? So let's say here you have Tropic of Cancer, here you have Tropic of Capricorn. So what happens in the summer region? Summer times means what? Summer times means the in the June time. June time, what happens? The sun will be over Tropic of Cancer. So what happens? This is Mediterranean will be still above the Tropic of Cancer. So since sun will be somewhere near the Tropic of Cancer, the subtropical high, that is the pressure belt, would have moved up. Pressure belt, because ITCZ will be here. Wherever the sun is there, ITCZ will be there. When ITCZ is here, the subtropical high belt will be somewhere here. So because of which the pressure will be high. So that is why summer there is no rainfall. Whereas in the winter I told you it is under the influence of westerlies. What happens? This subtropical high will move to the southern hemisphere, or it will move towards the equator. So what happens? This will come. So westerlies would be during the summer, it will be somewhere here because subtropical high is here. So what happens? When the subtropical high moves down, westerlies will also come down, right? So they will flow over the Mediterranean. That is why in the winter region, winter time, you have the westerly flowing in the Mediterranean region. In the summer region, it is subtropical high. Okay. Then you have so here you will find the because of westerlies. So in the summer you won't find rainfall. In the winter you will find lot of rainfall here, right? So summer will be very hot. Next you have the marine west coast climate. Marine west coast climate. Where will this climate be? So this will be found on the west coast of northwestern Europe, west of North America. All these areas you will find this type of climate. So here in the marine west coast climate, it will be under the influence of what? In the marine influence. Marine influence means ocean influence will be there. So because of influence of the ocean, the temperature will be moderate. Means it will be neither too hot nor too cold in the marine climate, right? So in the marine west coast climate, this is the thing. So here there will be no dry season because it is under the influence of ocean. Always there will be the ocean will act as a moderator. Also there will be warm and cool summer. So summers will be during the daytime it will be warm, night time it will be cold. Next we will talk about the cold snow forest climate. Cold snow forest climate. So this is found between the 40 degree to 70 degree north. Okay, it is found only in the northern hemisphere, 40 to 70 degree north, under which what you have? So you have humid continental and also subarctic. These are the two types. So here humid continental, there is severe winter. Here also winter is very severe. The symbols are not very important. So subarctic, where do you find this subarctic type of climate? In the cold, under the cold category. This you will find it in the northeastern Asia region. Northeast Asia, you will find the cold subarctic climate. Arctic, subarctic means what? It is not purely Arctic. It includes half the characteristics of the Arctic region. So you will find it in the Northeast Asia, that is Russia. Northeast Russia region. So here in this here you will find the influence of the anticyclones. Anticyclones will be there, and also here in the subarctic region there will be seasonal reversal of wind. Seasonal reversal of wind means what? So in one season wind will be blowing in one direction. So in the other season wind will be blowing in the opposite direction, just like our monsoons. right? That is there in the subarctic region. So that is not very important. Next is polar climate. So cold climate, you have tundra and polar ice cap. So in tundra there is no summer at all, and in the polar ice cap there is perennial ice. That is, there will be ice for continuously, there will be ice, right? Okay, polar climate, tundra, you will find the some special vegetation, that is mosses, lichens, right? All these mosses, lichens and all these things you will find in the tundra region. So here subsoil will be permanently frozen, means what? The soil. So beneath the ice, whatever the soil is there, that is permanently frozen in the tundra region. Then you have ice cap climate, polar ice cap here. So this ice cap is found in the interior Greenland and also Antarctica. In the interior Greenland and Antarctica region, you will find this ice cap. So here the temperature will be below freezing point. Ice cap, you can understand. Then you have highland climate. So highland means wherever, what is highland is simple. Wherever there are mountains, big mountains, Himalayas, Alps mountain, Andes mountain, Rocky mountains, there at the top altitude, at the highest level of the mountain, you will find the highland climate. This is, there is no latitude for this. Wherever there is mountain, you can find this highland type of climate, but there should be very proper big mountain, not small mountains, right? So next we will talk about the climate change. So he has grouped it into multiple things. So 6 types. So I discussed already: tropical, dry climate, wet temperate, cold snow, forest climate, cold climate and highland climate. So here tropically the lowest temperature is 18 degrees Celsius. In the dry climate, evaporation exceeds precipitation, means what? Rainfall, the evaporation will be more than the rainfall in the dry climate. That's why there is the desert. Then warm temperate. Warm temperate is, so the temperature range is between -3 degree and up to 18 degree. So all these European regions, you will have this warm temperate. Cold snow forest climate is, coldest month is -3 degree or below. So the temperature in the coldest month will be below -3 degree. That is the cold snow forest climate. Then cold climate, you have all the months. Across all the months, the temperature will be below 10 degrees Celsius in the cold climate. So this is highland is cold will be due to elevation, due to height, UT, Munnar, all these places. So this is about the climate group according to Koeppen. Now we will talk about the climate. Now we will talk about the climate change. So this climate, whatever you say, what is the difference between climate and weather? See, climate is over a long period of time, right? Weather is short-term changes. So when you ask somebody, what is, you will ask, you don't ask what is the climate. You will ask what is the weather in your place. Is it rainy? Is it sunny? Is it cloudy? Is it windy? Right? So all these things. So climate is a long-term period. So for example, the climate of Delhi is called as extreme climate. So too much summer, too much winter. Right? So Bangalore weather is called as a moderate climate, right? So Bangalore weather is a moderate. So that's why. So there are various type of climate. So this climate is whatever we call as climate generally. So we speak in the last 10,000 years. What has happened in the 10,000 years? So in the 10,000 years, millions of years there is. So when you take the climate, there are changes in the glaciers. So glaciers are changing. Some glaciers are moving up. Some glaciers are melting. So that is there. And also there are lot of ice ages. So you might have watched the movie Ice Age. So it is actually ice ages are coming and going over the earth every now and then. So it is not frequent over millions of years. Then also, how do you find the climate change is happening means if you see the trees. So if you see the trees, in the trees they will do the carbon dating. So in the carbon dating, in the trees there will be rings. So if this is a tree, there will be rings like this. So if there is a fossil fossil of a tree, if you see the rings, you can actually find out what climate was there when the tree was existing, right? So based on the trees, climate can be found. So, but unfortunately, this climate is changing. Why? Because of post-industrial revolution, human pollution, there is lot of pollution is there. In the 1990s, during the 1990s, there is the temperature were highest. So 1990s, the decade of between 1990 to 2000 is called as, so there was highest temperature decade was there. So for climate change, there are two causes. One is natural cause, another, actually there are both are natural cause. The first one is astronomical causes. Astronomical causes means causes in the space. So what is that? Sunspot. Do you know what is sunspot? So in the sun, in the outer corona region, in the not this corona, in sun also there is one layer called corona. So on the surface of the sun, there are dark spots emerging, right, every now and then. Here this layer will be actually colder. So sun temperature is something around 6000 degrees Celsius. This cold region will be around 2000 degrees Celsius. So it will be colder. So these are sunspots. So whenever there is sunspots, the climate will change on the earth, right? Climate will become colder. Sunspots, more the number of sunspots, lesser the temperature on the earth. Sunspots is lesser, warmer the temperature. That is one thing. Then you have the second astronomical reason is Melanchovic Oscillation. What is Melanchovic Oscillation? So what happens? So around the sun, the earth is revolving, right? Earth is revolving. So this earth, sometimes it will not follow the orbit properly. Sometimes there will be some changes in the orbit. So that is called as variation in the earth's orbit is called as Melanchovic Cycle. So when the orbit changes, then also climate will change on the earth. So earth will wobble. Sometimes earth will wobble. Wobbling means what? Shaking. So earth will shake sometimes, that is also there. And also axial tilt. I told you this is 66 degree and a half. So this it is bent 66 degree and a half. So because of that also the climate will vary, right? If the axial tilt, if it changes, then also climate will change. This is astronomical regions. Then you have terrestrial regions found on the earth. So what are the terrestrial regions? One is the volcanism. So because of the volcanoes. So what happens when the volcanoes erupt, what happens? There will be lot of aerosols. Aerosols means the volcanic ash, dust, all these things will go into the air and they will be rotating around the earth. So because of which what happens, the temperature will reduce, right? Because this dust will not allow the sunlight to come to earth. So because of which what will happen? The temperature will reduce. That is also responsible for climate change. And also the last but most important reason is greenhouse gases. I have discussed what is greenhouse gases already, right? Next you have this concept of global warming. So because of greenhouse gases, we have the global warming. So you know that greenhouse gases let the small wave inside, long wave radiation, it won't allow to pass outside, right? So because of which earth is warming. Which are the global warming gases? You have carbon dioxide is there, chlorofluorocarbons is there, nitric oxide is there, methane is there, ozone is there. So ozone, where do you find ozone? In the stratosphere. So what does the ozone do? It will not allow the UV radiation to come to earth. So it it acts like a blanket to the earth, right? So this and also you will find the temperature anomaly. So because of the global warming, there is temperatures are changing over various places. So this is the whole concept of global warming, and you will study it in detail in the environment part. For geography, this is more than sufficient. Next, we will talk about the water and ocean. So earlier what we talked was, the chapter was on rainfall and other things. That is the water cycle properly. Now we will talk about the water in the oceans. How the water moves in the oceans. So waves, currents, all these things are important here. So when you talk about the water, so where do we find water on the earth? Water in the solar system, you will find only on the earth, right? So it is a rare commodity. It is not available everywhere, right? So that is why earth is called as what? Blue planet. Earth is called as blue planet because of the presence of water, right? So the cycle of the water is called as hydrological cycle. The cycle of water in the through the atmosphere, biosphere and troposphere, atmosphere and biosphere is called as, and hydrosphere is called as the hydrological cycle. So water is a cyclical resource. Cyclical means what? So it goes through the evaporation, undergoes condensation and precipitation. Again it goes through the evaporation, right? So water is a cyclical resource, that is from ocean it comes to land, from land it goes back to the ocean, right? So this hydrological cycle, that is this cycle is happening over thousands of years, more than billions of years. This cycle is happening between the oceans and the earth, right? Is the water distributed equally across the world? No, it is distributed unequally. Even on the land, the distribution is different. On the oceans also, it will be different. So water, how does it circulate? What are the types of water you will find on the earth? You will find it in the liquid, solid and gaseous form. Gaseous form is water vapor. Liquid, solid form is ice caps, right? So where does this cycle takes place? This water cycle, it takes place between oceans. From oceans it goes to atmosphere, from atmosphere it goes to land, and from land it goes to subsurface, that is groundwater. So here you will find the water cycle properly. So whatever, if there is 100% of water on earth, 59% will undergo evaporation before retaining the earth. 59% of water will undergo evaporation. So this is the hydrological cycle. Evaporation, condensation, precipitation, transport by wind, advection. I told you, advection is horizontal movement, horizontal transfer of the temperature, right? So advection, here also condensation will take place, precipitation, evapotranspiration. Transpiration is from the leaves, right? From the plants, transpiration will take place, runoff to the oceans, right? So here it will penetrate into the soil, and in the underground the water will flow. This is the hydrological cycle, the proper hydrological cycle. So this is actually very simple. So in the oceans you find 97% of the water is lying in the oceans, right? So how much percent of our earth is filled with water? 70%. So out of that 70%, 97% water is in the oceans. So in the ice caps you find just 2%. In the exams they will ask this. So highest is in ocean, second is in ice cap, third the ice cap and glacier, third is in groundwater. So what you find as lake, it is only 0.01%. What you find in the soil is 0.005%. So this is the distribution of water in the world. So top 5, so atmosphere has just 0.000001%, right? So you should know this, right? Rivers has just 0.0001. This table you have to by heart. It is very, very important. Next, so water components, and so water storage. So in the oceans, what will happen? In the oceans, there will be evaporation, evapotranspiration and sublimation. So what is sublimation? Conversion from, direct conversion from solid into ice, or solid into water, or water into solid. Solid into gas is called as sublimation, direct, right? So then you have water in the atmosphere, you will have the process of condensation and precipitation. I have discussed this. So water storage in the ice and snow, that is in the glaciers, snow will melt and turn into rivers. Surface runoff, that is on the surface of the earth, you have fresh water in the form of rivers, right? Groundwater discharged through springs. So this is the storages of water and the processes taking place. Okay. So next we will talk about the oceanic deeps, oceanic floors. So relief of the oceanic floor. Relief. Relief means that is what is at the bottom of the ocean. I have discussed it already, but I will discuss it briefly. So the relief means what is there on the surface of the ocean. Is it a plain? Is there any mountains? Is there any valleys within the ocean floor? Right? So that is the relief of ocean floor. Ocean floor. So first, this ocean floor is actually 3 to 6 kilometer below the surface of the ocean. So if you see the surface of the ocean, the average depth is 3 to 6 kilometer, right? So this there are various features of the ocean floor. What are the various features? So you will find the mountains within the ocean. You find the mountains within the oceans. You find trenches. Trenches means they are valleys. So in the mountains, how you see valleys? So just like that, deep points in the oceans are called as trenches. You will find trenches. You will also find plains. So this is the relief. So how this various type of relief is formed? How is it formed? Because of various reasons. So I told you geostrophic movements. Geostrophic movements means land building forces. How the land is built on the surface. Similarly, in the oceans also land is built. So you have tectonic forces. Tectonic forces is one. Volcanic forces is the next. Third is depositional forces. So tectonic, volcanic and depositional. These are the three things. So tectonic means what? Plate tectonics. Because of the movement of the plates, ocean floor is formed. Because of volcano, it is formed. Because of deposition. Deposition from where? From the rivers. So from there also ocean floor is formed. So there is how the ocean floor is divided. So you find the ocean floor division into multiple things. One is the continental shelf. I have already discussed. So where the continent ends in the ocean. So continental shelf. So it is a extended margin. For example, you have India's boundary here. So let's say here is Chennai. So the continent will run up to here. So this is the continental shelf. So how much of the continent is running in the ocean? That is the continental shelf. It is the extension of the continent. It is shallow. Shallow means it is not deep. So it doesn't have the average depth of 3 to 6 kilometer. So where this continental shelf ends, that point is called as shelf break. Can you see it here? Shelf break. Where the continental shelf ends, it is called shelf break. So average width of the continental shelf is 80 kilometer from the baseline. This is called baseline. This is Chennai, means from here to here it is average length is 80 kilometer. So but some places there is no continental shelf at all. So for example, if you take Chile, where is Chile? South America. There is no continental shelf. So South America, there is no western coast, there is no continental shelf. Next, you have sediments. So this continental shelf is based on sediments. Lot of sediments will come and get deposited in the continental shelf. So in these sediments, you will find lot of fossil fuel. You know, right? Mumbai High. So if you have visited Mumbai, what happens? So from some distance from the Mumbai, there are oil drilling. Digboy is in Assam. Huh? So that is not true. That is there. But what I am saying is, in the oceans, in the continental shelf also, you will find lot of oil. So in Mumbai, there are some oil drilling spaces in the Mumbai and off the Gujarat coast, right? That is found in the continental shelf, right? So that is one thing. Next, we will talk about continental slope. See, this is the continental slope, where the continental is sloping. So here the gradient is 1 to 2 kilometers, that is 1 to 2 degree. Whereas continental slope will be like this. The gradient will be high. So gradient will be 2 to 5 degree. 1 to 2 degree in the shelf or 2 to 5 degree in the slope. So here you will find the canyons and the trenches. Canyons and trenches means what? So they are valleys. So if the continental shelf is broken properly in the middle, that is the canyon and trench, right? So it is just like a valley, a mountain valley in the continental shelf. It is called as canyon and trenches. So you have this Hudson Trench in New York. So it is actually why does this canyon and trench will be there in the continental shelf means, see, some river will be flowing and the river will continue into the ocean. So it would have formed the proper valley. So canyon and trench in the oceans. So next you have deep sea plain. In the deep sea plain, this is the deep ocean basin. So here it is a proper plain. So here I have a continental slope. See, this place is called continental rise. Once the continental slope where it ends, it is called as continental rise. So till here it is called as continental margin, that is till here. Then you have, this is deep ocean plain. In the deep ocean plain, it is also called as abyssal plain. Abyssal plain, it is flat and the depth is 3000 to 6000 meters, and you will find lot of clay and silt in the region. It is also called abyssal plain. Here you will find some other reliefs, goyards and seamounts. I will discuss what is goyards and seamounts. So here also you will find the deep ocean trench. I have discussed what is trench. It is deepest point in the ocean. Next you have the oceanic deeps and trenches. Here it comes. Deep oceanic deeps and trenches. So they will have very deep, they are very deep within the oceans, deep places within the oceans. So here in these deep oceanic trenches, you will find the oceanic deeps and you will find the volcanoes and earthquakes. In the trenches only you will find the volcanoes and earthquakes. Very, very important, right? Okay. So this is about the next. We will talk about the minor ocean relief. Minor ocean reliefs. So first minor. So whatever I told till now, that is continental shelf, continental slope, continental rise, deep oceanic trenches. They are the major oceanic reliefs. Now I am talking about the minor oceanic reliefs. So the minor ones are what? The first one is mid-oceanic ridges, where I have given the example of mid-oceanic ridges, Atlantic Ocean. So mid-oceanic ridges is there. So what is ridge means? So see, there will be two mountains. That is, there will be one mountain only. In the mountain at the middle exactly, there is one depression. Proper depression will be there. See, here there is a see, here there is a depression. This is the depression, this is the mountain. So this is the what? Mid-oceanic ridges. Two chains of mountains is there. In the middle there will be a depression, proper depression, right? So this is first thing. So you have this Iceland. Iceland is there. No, it is on the mid-oceanic ridge only. Iceland country is on the mid-oceanic ridge only. In the mid-oceanic ridge also you have fracture, you have a rift. Rift is a mid-oceanic rift means it is a broken, it is just like a fracture. So this is all about the mid-oceanic ridge. Okay. Okay, next you have seamounts. Seamounts means what? They are mountains. Here you can see the seamount. So they are mountains within the ocean. So they are mountains with pointed summits. So, but these seamounts, they do not reach the surface. They will be mountains within the ocean. So those are called as seamounts. So they can be volcanic. So in the seamounts there can be volcanoes. And where do you find this seamounts? The best example is in the Hawaiian Island. Where is Hawaiian Island? Which ocean? Pacific Ocean. Which country does it? Hawaii belongs to United States of America, right? So in Hawaiian Islands, you have this seamount. That seamount name is Emperor Seamount. Emperor Seamount is there. Then you have submarine canyons. I told you this is a canyon. That is it is just like a valley in the continental shelf. Where so they are deep valleys. They extend from the mouth of a large river. I told you here there will be some river will be flowing here. So from there the canyon will extend into the sea. So So the best, they extend from the mouth of a large river. The best example is Hudson Canyon, New York. Hudson River. So there will be a there is a proper canyon there within the ocean. Then you have guyats. What is guyats? They are flat topped seamounts. See, this is a guyat. That is at the top it would be very flat. Guyat is a flat top seamount. Then okay. Then you have atolls. What are atolls? So atolls, they are low-lying islands. See, atolls will be somewhere like this. So you know this Lakshadweep island, right? So it is actually found full of atolls. So or it is actually an island like this. Inside also there will be water, outside also there will be water. So here there will be some land like this, small lands coming out. So what is this land formed out of? It is formed out of coral reefs. What is coral reefs? I will discuss it in the environment section. Corals are living beings, right? So because of coral reefs, low islands are formed. So like this. So within also water is there. So at the center there will be water depression. Outside also there will be water. So you will find these coral reefs majorly these atolls in the tropical region. You won't find it outside the tropics, right? So this is all about the relief of the ocean floor. Now we will talk about the temperature of the ocean waters. What is the temperature of ocean water? So when it comes to temperature of ocean water, so it varies spatially and vertically. Means what? It varies horizontally. The temperature of Indian Ocean is different from Arabian Sea. The temperature of Arabian Sea is different from Mediterranean Sea. So it varies horizontally. It also varies vertically, right? So why does this variation? See, and one more thing is the temperature from land and ocean is also different because ocean heats up slowly. So here, see, this is the ocean floor andre. Heat will come here andre. So first top layer will get heated up. Slowly, this region will be very cold. They should also be heated up. That is why the heating should take place till here. Whereas land, only the top layer should get heated. Right? So that is why land will get heated very fast. Right? What are the factors based on which temperature of the oceans depend upon? See, the first factor is latitude. So if the places are in the equatorial latitude, the oceans will be warmer. Polar latitude, oceans will be colder. Then second part is unequal land and water distribution. See, if you look at the northern hemisphere, there is lot of land. If you look at the southern hemisphere, there is lot of oceans. So this will also influence the temperature of the oceans, right? So the land is there means there will be lot of heat. Then the third one is prevailing wind. So wind will also determine the temperature of water. For example, what happens? Let's say there is let's say take the Indian Ocean. What happens? Let's say here there is warm water, right? So wind will come from this side, from the Western Ghats wind will come and it will push the warm waters towards the Arabian Sea. So this space will get empty because warm water above surface warm water has been pushed away. When the warm water in the surface is pushed away, what happens at the bottom? There will be cold water. So that cold water will rise up to replace the pushed away warm water. So this is the effect of the wind. So upwelling in the offshore winds. So offshore winds means what? The wind moving from the land to oceans. That is offshore wind. It will push away the warm waters. So cold water will rise up. Whereas on the other hand, what happens? If there is onshore wind means wind coming from the oceans towards the land. It will push away the warm water towards the ocean, towards the land. So warm water will come and get collected here. So cold water will go down, right? So winds will also have a effect on this, and also ocean currents. Ocean currents will also have an effect on the temperature. So there are two types of ocean currents. I told you warm ocean current and cold ocean current. So if there is warm ocean current, the temperature will be warm in the water. Cold means cold temperature. So for example, the best example is the Gulf Stream. So where does the Gulf Stream come from? I'll show you where is Gulf Stream. See, yeah, here, from here, this is a Gulf, Mexican Gulf. From here, this Gulf Stream will go like this, and here it will go towards North Atlantic Drift. So this is going from the equator, right? Because of which the Gulf Stream will be hotter, since it is moving from the equator towards the poles. So what happens? This, since it is moving towards the North America, here, since it is a hot water, here the temperature will rise because of the warm ocean current, warm Gulf Stream, right? So then there is one more example, Labrador Current. So this Labrador Current, it will come from this region, Canada, between Canada and Greenland. It is a cold current because it comes from the polar region towards equator. It is a cold current. So what happens? Since it is cold current, it will make all this region cold. So this is the effect of the currents on the neighboring areas, right? So next you have the temperature in the enclosed seas. So let's say, see, in the lower latitudes, that is between 0 degree to 30 degree north and 30 degree south, in those latitudes, if there is a sea which is enclosed means there is no outlet for the sea to go, right? There the ocean water will be warmer. Why? So because the water is trapped, there is no river water or anything joining it, so water will be warmer, right? So in the higher latitudes, that is above 30 degree up to 90 degree, so up to 90 degree, if there is a enclosed sea, what happens? The water will be cold because of the temperature. So there will be no warm water mixing in it, so temperature will be cold in the enclosed seas. So next concept is horizontal and vertical distribution of temperature. How is the temperature distributed horizontally and vertically? So there is one concept called temperature depth profile, not depth profile, temperature depth profile. So what does it say? Temperature decreases with increasing depth. See, as a depth increases, see, this is the surface of water, surface of ocean. As the depth increases, temperature decreases. So this is the temperature depth profile. See, at the below, from if this is the surface, around some so the surface temperature will be around 27 degrees. Surface temperature of the ocean will be 27 degrees. As it goes down below the sea surface, some 400 meters below the sea surface, there is one layer called thermocline. Thermocline is one layer. So this layer, what happens? See, if this is the 0 degree, this is the surface, means till up to some 300 meter, the temperature will reduce slowly. From this 300 meter up to 1000 meter, where there is thermocline, the temperature will reduce very fast. That is why, see, temperature is reducing. But after 1000 meter, once the thermocline ends, the temperature will again start reducing slowly. Right? At the surface, slow reduction, thermocline, quick reduction. After thermocline, the temperature will reduce very slowly. Right? Okay. So there are 3 layers in the mid and low latitude. That is from 0 degree up to 66.5 degree. So there are 3 layers. Whereas 3 layers, what are the 3 layers? The first layer is up to 500 meter thick, 500 meter. So the second layer is here. So first layer is this layer, the temperature will be slow reduction, and second layer is thermocline. Second layer. So here 500 to 1000 meter, there is fast reduction. Then third layer is very cold layer, bottom layer, right? So it goes up to the ocean floor, So whereas this is with respect to the low and middle latitudes. What about the Arctic latitudes? That is the polar latitude. There are no 3 layers. There is only one layer, that is the surface will be 0 degree. At the bottom it will be minus in the minus. So there is only one layer in the polar region. There are no multiple layers, right? So I told you surface layer, the temperature is 27 degree. So this 27, does the surface temperature remains the same in the poles also? No. 27 degree, what I told, surface temperature, it is at the equator. But at towards the pole, it decreases. So how much does it decrease? Let's say at the equator, 27 degree surface water temperature. So every latitude, every 1 degree latitude, there is 0.5 degree Celsius reduction in the temperature. 1 degree latitude ಮೇಲೆ ಹೋದ್ರೆ 0.5 degree ಕಡಿಮೆ ಆಗುತ್ತೆ. For example, tropic of the subtropical high. Subtropical high is at which latitude? 30 degree. So by we reach the 30 degree, the temperature would have reduced by 15 degrees Celsius. So because it is half, right? Okay. So next you have this. When you look at the temperature of the oceans, I told you northern hemisphere oceans are having high temperature. Northern hemisphere temperature, average temperature is 19 degrees Celsius. Southern hemisphere ocean average temperature is 16 degrees Celsius, right? Okay, because of the excess presence of the land in the northern hemisphere. So this I told you at the top layer, surface layer, the temperature is very high. How does this temperature go to the bottom? Just see, in the atmosphere, whatever the temperature at the surface level, how does it go to the upper atmosphere? By convection, right? Similarly, by similar process, the temperature at the surface will go to the bottom by the same convection process, right? Similar convection process, the temperature will be transferred to the lower sections, right? So the same surface temperature towards the lower section, it will be transferred via the process of convection, right? So next you have, this is with respect to the temperature. Next we will talk about the, so this is the spatial surface temperature. So here at the ocean, at the 0 degree, you have approximately 27 degrees Celsius. See, at the polar you have surface temperature is 0 degrees Celsius. So it keeps on decreasing, right? Next, we will talk about the salinity of the world's ocean. That is salt content of the world's ocean. How much salt content is there? So why would be the see, first of all, please answer why there is salt content in the oceans. What is the necessity of salt contents in the ocean? Why? Because there is lot of minerals. So you have sodium, you have chloride, you have phosphorus, you have magnesium, calcium, everything is present in the ocean waters. How does it get added? Because of the sediments brought down by the rivers and also from the ocean floors. So because of this, minerals will be dissolved in the sea water. That is why it is salty, right? So how does the salinity is formed, is measured? So the amount of minerals dissolved in the sea water, in 1 kg of sea water, that is how salinity is formed. The standard measure is parts per thousand, PPT, parts per thousand. How many parts? For example, if 3 parts of salt is dissolved in 1 kg of water, so it is 3 PPT, parts per thousand. So that is, if there is 1000 parts of water and 3 parts of some salt, so it is 3 parts per thousand PPT salt, right? So it is measured in PPT with respect to 1 kg of seawater. So what are the factors which affects the salinity? Uppinamsha yadru mele depend agutte. So it depends on the evaporation and precipitation. So what happens if there is lot of evaporation? What happens? Water will get converted into water vapor. The salts will get concentrated. More evaporation, more salinity. Less evaporation, less salinity. See, water will go off. What will remain? Salt. So salt will increase. And if the precipitation is more, salinity will be less because water will get diluted. Fresh water will get added, right? Next, that is the first factor. The second factor is the fresh water flow from rivers and ice. If fresh water gets added, the salinity will reduce. The third factor is wind transfer. If the wind transfers the fresh water from one place to other place, salt water from one place to other place where fresh water is there, that will also impact the salinity. Not only that, in the ocean bound, in the continental boundaries, suppose there is highly saline water here. What happens if the wind takes the saline water away? So at the bottom there might be some less saline water that will come up, right? So that is there. So wind factor is also there. Then ocean currents. Ocean currents. So these currents will also transfer the salt from one place to other place. Ocean current will also impact the salinity of the water. Not only that, temperature and density. If the temperature is high, salinity is high because more evaporation. And density, if the density is high, salinity is high. Salinity is high means density, because see, more amount of salt is present in the water. Isn't the water will be thick? So water will be dense, right? So that is one thing. So which is the highest salinity lake in the world? So which is the highest saline lake in the world? It is a prelim question. It is Lake Van in Turkey. Lake Van in Turkey is the highest salinity lake in the world. The second lake is Dead Sea, next to Israel, between Israel and Jordan. Dead Sea is the second highest lake. So if you go and jump into the Dead Sea, you won't sink because water is denser, right? So which is the deepest lake in the world? Lake Baikal. Lake Baikal in Russia is the deepest lake. So you should know these factors for the prelims, right? Not UPSC, but state services they will ask. Next, this is we will talk about the horizontal distribution of salinity. How salinity is distributed across the world horizontally, right? So how, see, what are the lines which connect the places of similar temperature is called isotherms, whereas the lines which connect the places of similar salinity is called as isohals. Isohals or isohalanes? I'll see that. So average. So what is the average salinity of the world? What is the average salinity of the world? World's oceans. So it is 33 to 37 ppt. It is isohalane. Isohalane is the line that join the lines of equal salinity, right? So the average salinity is 33 to 37 parts per thousand. So salinity is higher in the landlocked places. So if there is a lake which is surrounded by land, so their salinity will be higher because there is no inflow of fresh water. Also evaporation will make more the lake very, very salty, right? So landlocked region, the salinity will be high, and also hot regions, equator, salinity will be high. Why? Because more evaporation, salt will get concentrated, right? And also North Sea, see here, this is North Sea, somewhere here is North Sea. So equator salinity is high means polar region salinity should be low because fresh water will flow into the, from the ice will flow into the oceans. But since this place, even though this place is close to the polar caps, here salinity is high because why? This Gulf Stream will carry the salt towards the North Sea. Salt will be carried by the Gulf Stream towards the North Sea, because of which salinity will be high. So this North Atlantic drift, once the Gulf Stream reaches here, it is called as North Atlantic drift. There is one more thing, one more current, it goes like this, it is called Canary current. We will discuss the currents later. So Indian Ocean, what is the average salinity of Indian Ocean? It is 35 parts per thousand, 35 ppt, right? Arabian Sea has higher salinity than the Bay of Bengal. Why? Because Bay of Bengal, lot of rivers are going and merging, because rivers means fresh water, so salinity is low in the Bay of Bengal. Whereas Arabian Sea, not many rivers will flow. That's why salinity is higher, right? So vertical salinity. Next we will talk about the vertical salinity. See, this is how salinity is distributed. So the lines connecting point of equal salinity. This is not important. You can just see where there are lines of high salinity. See, Indian Ocean, it is 35 salinity, right? Okay. So when it comes to salinity, vertical salinity, at the surface salinity is higher. Why? Because the loss of water, because of evaporation, water will go off and salt will get concentrated at the surface, because of which salinity is higher at the surface level. But at the surface level, salinity can sometimes be lower when the fresh water flows into the surface water. See, fresh water doesn't have any salts, so they flow into the surface water, the salinity will become lower. But if there is evaporation, salinity will be increasing. So, but at the depth, at the surface layer, this is what is happening, right? It might increase, it might decrease. But at the lower level, salinity is constant. It will not change, right? It is a fixed salinity. So, at the lower level, high salinity will be there. Since high salinity is there, lower layer is having high density. Salinity is high, density is high at the lower level. Upper layer, salinity is low. Salinity is low, so density is lower, right? So, salinity increases with depth. So, as you go down, the salinity will increase. Temperature decreases with depth, right? So, this just like the thermocline, just like thermocline, there is one more line called halocline. So, just like where temperature reduces abruptly is called as thermocline, where salinity increases abruptly, it is called as halocline. Halocline, right? Okay. So, this is about the salinity of the water. Next, we will talk about the movement of ocean water. How does the ocean water moves, right? So the ocean water moves either horizontally or vertically, right? How does the ocean water moves horizontally? So there are multiple ways. So one is, if you visit a beach, you will see waves, right? Isn't it horizontal motion? The waves is the horizontal motion of the oceans. One more horizontal motion is currents. So current means it is a river within the oceans. So current also, water is moving horizontally. So these are the two ways the horizontal movement takes place. So in this current, I will discuss what is a current later on. There will be huge water will be moving just like a river in the oceans, right? So in the current, there is difference between current and waves. So in the current, what happens? The actual water will move from one place to other. So if there is a current from Indian Ocean to Pacific Ocean, the actual water will move from here to there. Whereas in waves, the water will not move. The water will just go up and down. Whereas the waves will move. See, if you think that in the ocean, actually the wave water is coming towards you, it is not. Water is stationary. Water is doing a circle at the same place. Rather, the wave energy is moving towards you. There will be a wave energy. Alegal mata bartave, but water alle irutte. It will form like a cycle. It will fall up and down, right? That is horizontal motion. Vertical motion, you have tides. Tides, I will discuss what is tides. So, tides, see, once you just know this, that if you see some beaches, sometimes the water will come close to the shore. Sometimes it will go backwards. So it is called high tide, low tide. So that is because of gravitational pull of the sun and moon, right? So it is sometimes called as upwelling. The water, ocean water is upwelling towards the seashore. Sinking means it is going back. So this is with respect to the tides. First, we will discuss the waves, motion of waves and water molecules. So here the energy moves. The wave energy is moving, water is not moving. So water just travels in the circle, right? See, they have shown the circle. So water is just traveling in the circle. So this point is called crest. This point is called trough. The bottom point is called trough. So wave is traveling towards the right. Okay. So how does the wave get energy? They get energy by the wind movement. Wind is actually creating the wave. There is no other energy. When wind blows over a surface, it creates waves, right? So wave is where is the energy wave gets from? It is mainly because of the wind. There is no other energy for waves. Clear? Okay. So when this wind flows over the water, what will happen? It will drive the water, it will push the water and wave gets created. So if the wind is very strong, the waves will be of very height. The height will be very large. If the wind is less stronger, the height will be low. Stronger the wind, higher the wave. Clear? Okay. So this energy is there. See, this energy is moving, right? So where does this energy dissipates? Where does this energy end? At the seashore. So let's say here is the seashore. This wave will come and crash at the seashore. So that is called as, what is that clashing is called as? So it is called as wave break. So wave will come and break at the beaches, right? So that is why everybody enjoys playing at the beach, because wave breaks there and water will be pulling backwards from the bottom, and from the upwards it is coming towards the wave, towards the seashore, right? So that where the energy breaks is called as, it is at the seashore, is called as wave break, right? So as in the deep oceans, when the wave is moving in the deep oceans, it will be having very high speed. But as it approaches the seashore, that is the beaches, the waves speed will reduce. The speed of the wave will reduce. Why will it reduce? See, here the wave is moving in the deep ocean, it will be fast. Once it reaches the seashore, what happens? It will encounter friction from the ground. So ground will come upper, right? As we move closer and closer to the seashore, the wave will find the ground. So friction, because of friction, the wave will slow down and later on break, right? The standard formula is, if the depth is half the wavelength. So first you should understand what is wavelength. So wavelength is between two crests or between two troughs. The distance between two troughs or two crests is called wavelength. Right? So when does the wave break? When does the wave break on the seashore? When the depth is half the wavelength, that is height of the wave. Height of the wave see, this is a wave alva. This is the height. Oh, sorry, this is the height. From 1 second. This is amplitude. This is the height of the wave. So this height, it is less than half the wavelength, then the wave will break. When the height of the wave is less than half the wavelength, then the wave will break, right? So in the deep oceans, open oceans, there will be large waves, but as it comes to seashore, there will be small waves. So as it hits the seashore, it is called as surf. As it hits the seashore, it is called as surf. So the name surf excel is derived from this, that when the wave hits the seashore, it is called as surf. So there will be lot of this, what do you call? Foam. So there will be lot of foam. So that is why the surf excel. the names. That is called as surf. So I told you the speed of the wind is higher, the length of the wave is more, right? So if the waves are very steep, if they are very tall waves, it means they have originated in a close distance, right? If they have originated in the close distance, but if the that is if the wave is smaller, or if the wave is slower, it means it has originated in the far place. If the wave is coming very slow and it is steady, slow and steady, its length is also not very steep, that means it has come from a different place, from a far off place. But if you see a very steep wave coming very fast, it means it has originated somewhere nearby to the seashore, right? So on the one hand, the wave is being pushed towards the seashore. The wind is pushing the wave towards the seashore. On the other hand, the gravity is pulling the wave towards ground. That is why you find this kind of picture, right, in the waves. So wind is pushing, gravity is pulling, right? That is why you find this kind of wave picture. So some of the characteristics of waves are crest and trough. I've told you what is a crest and what is a trough. So crest is the top point, trough is the smallest point. Height is from the crest to trough. What is the height? That is the height of the wave. Amplitude. Amplitude is half the height. So entire thing is height, whereas amplitude is half the height. Half the height is amplitude of the wave. Then you have the concept of period. Period andre the how long does it take for the wave to move from one crest to other crest, or from one trough to other trough. So let's say here is a point. So the trough is, this point will move first. Let's say the wave is moving in this direction. This point will move first. Let's say we will, once this point moves this line, we will start the stopwatch. Then we will stop the stopwatch when this point moves, right? So let's say between this point and this point, there is 2 seconds. So 2 seconds is the period of wavelength, right? Then wavelength I have discussed, it is between 2 crests and 2 troughs. Then you have wave speed. So if you measure the speed of the wave, how is the wave speed is measured? It is measured in knots, Knots, right? Wave speed is measured in knots. Wave frequency means what? So in 1 second, how much in 1 second how much the wave moves? So wave periodally, what happens? It is between 2 successive points. How much the wave, in what time the wave has moved between 2 successive points. Whereas wave frequency, in 1 second, how much the wave has moved. Wave period, wave second, it is actually inversely proportional. Frequency is inversely proportional to period. So wave frequency is always measured with respect to 1 second. Period between 2 successive points, right? Okay. So next we will talk about the concept of tides. So we'll talk about the concept of tides. So this tides means periodic rise and fall of water. So periodic rise and fall. So tides, let me show you a diagram, else it will be difficult. See, the same place during high tide it is filled with water. Same place. See, during low tide there is no water. Right? This is the concept of high tide and low tide. Clear? So why does this happen? It happens because of the gravitational pull of the sun and moon. It happens. Did you understand the concept of tides? It is very important. I myself did not. See here also, see, till here the wave has come during high tide. Whereas see, during other time the water has receded. This is the concept of tide. Okay. So it is very important. I myself had not understood it for 1 year. Concept of high tide and low tide. Okay. So it is because of sun and moon pulling, gravitation pull, this high tide and low tide will happen. So here this tide is different from surges. There is this concept of tide. Another concept is there called surge. Surge is different. Surge is because of meteorological effects. Meteorological effects andre, it might be because of wind, or it might be because of temperature or salinity or pressure, right? Because of these regions, if the water level increases, it is called a surge. Whereas tides, and that surge it is irregular, whereas tides are regular. Tides is because of the gravitational pull, right? So this tide is because of two reasons. One is centrifugal force and the gravitational force. These two forces are called as tide generating forces. So gravitational force of what? Gravitational force of the moon and sun. That is one thing. And the centrifugal force. What do you mean by centrifugal force? What is centrifugal force? So it's better to show a diagram. This is the best example. See, if you are rotating this ball, right? So what happens? It will be moving outside, right? As soon as you release it, it will not come towards you, it will go away. That is a centrifugal force, right? So similarly, Earth will also has a centrifugal force. Why does Earth has a centrifugal force? It is rotating, right? Anything rotating will have a centrifugal force. That's why, see, because of gravitational force of the moon and sun, the waves are moving towards this side. But on the other side there is no gravitational force because of the force of the centrifuge. You yourself rotate speedily. So actually you will be like, you will be knowing this, right? Small kids, they will be wearing frocks and they will rotate, and it will be, the frog will be, so it is because of the centrifugal force, right? So science is something which is relatable to everyday life, right? So that's why the Earth, if it is rotating, the tides will also move away. That is the centrifugal force. So because of these two things, you have the tides on both the sides of the Earth, right? Okay. The balance of centrifugal and gravitational force. So two major tidal bulges. So one is towards the gravitational force. This is one tidal bulge, right? So this is a closer end, closer towards the sun, and there is a farther end. This is farther from the sun and moon. There you have centrifugal force, right? Okay. So there are other factors also. Not only gravitation and centrifugal force, there are other factors also. For example, the other factors is whether there is a bay, what is the wind direction, right? And what is the gravity at that place, right? So what is the rainfall? All these things, what is the temperature? Those things also will impact the tides. So when tides are moving. So when the tides are channeled into islands, let's say tide is moving like this. Suddenly here there is an island, and here there is an island. Here there is land, here there is land. So tide is forced to go into this, right? When it is forced to go into a particular direction, the tide will become tidal current when it is moved in a narrow direction. So once the best example is for the tides is Bay of Fundy, Canada. So there you can witness the highest amount of tides. Bay of Fundy in Canada. So what are the types of tides? So tides are classified based on frequency and height of the tide. So based on frequency, how frequent the tides will occur. Based on that, tides are classified as semi-diurnal tides. Semi-diurnal tides means what? Daily there will be 2 high tides and 2 low tides. When this is there, it is called as semi-diurnal tides. Then there is diurnal tides. ಅಂದರೆ 2 high tides ಅಂದ್ರೆ 2 ಸಲ ನೀರು ಏರುತ್ತೆ 2 ಸಲ ನೀರು ಇಳಿಯುತ್ತೆ. That is semi-diurnal. Diurnal means 1 high tide and 1 low tide. Right? Then you have the mixed tide. So this is with respect to frequency. Then one more concept you have with respect to height of the tide. So when there is a height of the tide varies. Sometimes the height is more, sometimes the height is less. That is called as mixed tide. Mixed tide is with respect to height variation. You will find it in the west coast of North America. This mixed tide. Then you have one more type of tide that is with respect to sun, moon and earth position. Position of the sun, moon and earth. There is tides. So here also the height varies because of the position of the moon, earth and sun. The tides will vary. Height of the tides will vary. So the first type of tide is because of this gravitational pull is the spring tide. Spring tide means what? Sun, moon and earth all are in same direction. All are in straight line. When they are in straight line, you witness what? You witness high tide. Earth, sun, moon and sun both are in straight line. You witness what tide? Spring tide. So you see this twice a month. Once when the moon is here, once when the moon is here. Right? Okay. So when the moon is here, it is called as what? Full moon or new moon? So when the moon is here, it is called as new moon. Amavasya. When the moon is here, it is called as full moon. Right? So then you will see the spring tides. Then you have neap tides. When do you see the neap tides? So you will see the neap tides when the moon is here or here. So they are in perpendicular direction, 90 degree. Right? So that is when you will find the neap tides. They occur exactly 7 days after the spring tide. 7 days after the spring tide. So here what happens? This force, see, here moon is there, earth is there, sun is there. This force is counteracted by this force. So there will be counteracting force. So this force will cancel this force. Right? So there will be less effect. So this is with respect to neap tides. Then you have one more concept. When the moon is close to the earth. Moon is rotating in 24 hours around the earth, right? So when the moon is very close to the earth every day, then that position is called as perigee. Perigee. So there high and low tides will be there. Very high tide, very low tides will be there. So there is high range. So high tides is sikkapate high tide, low tide is sikkapate low tide. So the range will be very high. So that is one thing. When the moon is at apogee, apogee and the moon is at the farthest place from the earth, then the range will be lower because the effect of moon will be less. Then you have one more concept with respect to position of the sun. When the sun is at the perihelion, perihelion andre earth is closer to the sun. Then when is it? It is on 3rd January. Right? Then you have very high tide and very low tide. High range is there. But on the aphelion, when the earth is closer to the sun, then what will happen? That is when, on which date? 4th July. 4th July, the earth is closer to the sun. Right? Then the range is less. There is very less high tide, very less low tide. The range is very less. Okay. So this is with respect to tides. So the last concept with respect to tide is the, see, I told you from high tide, there is high tide and there is low tide. Between high tide and low tide, the water is falling. So this falling water is called as ebb, EBB. Falling water is called as ebb. Whereas between low tide and high tide, from movement from low tide to high tide, the water will be rising. It is called as flow. The rise of water is called as flow, right? Okay. So what are the importance of tides? Why tides are important to us, right? So one is, see, the tides are dependent on the position of the sun and moon, right? So we can predict the tides very advancedly. So we can predict it in advance that this tide will go and happen in this time only. Based on that, we can plan. We can tell people not to go to the sea because sea will take you away. And there is one more thing called navigation. So what happens? I told you there are barrier bars. So when there is, let's say this is the Indian boundary, here there will be barrier bars, that is sand bars will be there. What happens? The ships cannot come when there are barrier bars are there. They will get stuck. So when there is high tide, what happens? With the tide, the ship can come to the harbor because water level will increase, right? And it can stay there. But again, when going back, there should be high tide. It can go back with the high tide. So what these fishermen do? They will flow with the they will go back with the low tide because low tide water will be withdrawing, and they will come back when there is high tide. They can easily come back. So that is how in navigation they will use it. And also tides are important in desilting sediments. What happens in this Hooghly river and all? There is lot of sediments, debris. So when there is low tide, what will happen? They will clear the debris, right? That is also there. Then also the tides can be used for electric power, tidal energy, right? That is also one of the use. So this is with respect to tides. Next, we will move towards the oceanic currents. Very important. Oceanic currents. As I have been telling again and again, oceanic current means river flow in the oceans. Rivers in the oceans are called as currents, right? They have a proper direction and path. They cannot go anywhere. They will be going in a proper direction, right? See, these are the currents. So in the Indian Ocean, you have this, Indian Ocean, there are not many currents, known currents. See here in the Japan current, see, whatever the current that goes from equator towards the north, it is a hot current or a warm current. Whatever the current that flows from the polar region towards the equator, it is a cold current, no exception. That is how it is. So you have hot current, see, from the equator it is going Kurashio. Kurashio is a hot current next to Japan. From the north you have Oyashio. It is a cold current. Current names are very important from your exam perspective. They are going to ask which current flows where. I will discuss. So oceanic currents, so there are two forces for the currents to form. One is primary and secondary. What are the primary forces? Solar energy. Because of solar energy, that is, see, when sun rays fall on the ocean, what happens? There will be heating, right? So let's say at the equator there is lot of heating. So when the heating happens, what happens? The water will expand. When water expands, what happens? The water will rise in the equator level, whereas polar level water will not expand. There the density is higher, water will be at lower level. So equatorially water is high, polar the water is low. What happens? Water will flow from equator towards the polar. Clear? This is how the currents are formed, right? Next, so there is a gradient from, that is a height difference between from the equator towards the poles. That is one thing. And also wind is also responsible, just like how wind is responsible for generating waves, wind is also responsible for pushing the oceanic currents. I told you the winds will push the ocean currents, leading to upwelling of water. Bottom water will come up when wind pushes the surface water, right? Then you have gravity. See, where is the gravity higher? Is it at the equator or at the poles? Gravity is higher at the poles, because from the distance from the center of the earth to pole is very less. Gravity will be higher. From the center of the earth to equator is more. So what happens? Since gravity is more at the poles and less at the equator, water will flow from equator towards the poles, right? That is also a factor. Then Coriolis force. So I told you, in the northern hemisphere, the wind will get deflected clockwise towards the right, southern hemisphere towards the left. So that will also push the water. So that is also a current generating force. Oceanic current, not the regular current. So because of the Coriolis force, there is one concept called gyres. Gyres. So gyres, I think it's better to show a diagram. What is gyre? So it is just like a cyclone in the ocean. Say gyres are just like cyclones in the ocean. So what is gyre? I'll show you. So it is a, see, the circulating, can you see the circulation? This is a gyre, right? So because of the Coriolis force, see, since this is northern hemisphere, right? See, northern hemisphere wind will be deflecting towards right. So there is a proper gyre. See, southern hemisphere wind will be deflecting towards left. So gyre will be in the anti-clockwise. Clear? Okay. So this water will be moving, right? So this water movement is called as drift. Movement of water is called drift. It is measured in knots. K-N-O-T-S. So this water surface, the movement is strong at the surface. The movement will be faster at the surface because there will be lot of force at the surface. Whereas bottom water will be moving very slowly. Bottom water will not move faster, right? So that is one factor. There is one more factor, the difference in the density, right? So while density will differ based on two reasons. One is salinity and the other is temperature. See, saline water, is it denser or less denser? It is denser. So equator level, the water is highly saline or low saline? Highly saline because of evaporation. Polar level, low salinity. So from denser, from equator to polar, the water will flow. Clear? Then that is one thing. And also temperature. When there is, since there is temperature change, the water will move from one place to another place because to maintain a temperature equilibrium. So that is why we have this cold current as well as warm current. So what are the types of current? The first ocean currents. The first type of division is as the surface current and deep current. So surface current andre which flows at the surface. This is just 10% of water. So up to 400 meter from the surface current will be seen. The next one is deep current. Deep current is includes 90% of the water. Deep current is to 90% of the water will be there. So they will be 90%. So based on temperature, there is one more division, cold current and warm current. So where do you find the cold currents? In the low and middle latitudes. That is, see, this is low and middle latitude is up to here. In these latitudes, you will find the cold current on the west coast. See, west coast, there is cold current. There is, see, these dot are all cold current. West coast, this is a west coast cold current, right? And see, west coast in the middle latitude, there is cold current, right? But at the high latitude, you will find the cold current on the east coast. See, east coast you will finding the cold current. Here it is there. See, here it is there, east coast. See, here it is there, east coast. Here also it is there, east coast. Right? Okay. Sorry, here it is there. This is actually west coast. So here it is there. So at the higher latitudes, because this comes under the lower latitude. So higher latitude you have the cold current. Whereas warm current, lower and middle latitude, you will find it on the east coast. See, up to here it is lower and middle latitude. Warm current you will find on the east coast. See, warm current on the east coast, warm current on the east coast, warm current on the east coast, and warm current on the east coast, lower latitude. Higher latitude, you will find the warm current on the west coast, above 60 degree. See, warm current on the west coast, warm current on the, it's not there. Here you can see warm current on the west coast, higher latitude. That's all. So this is with respect to the cold and warm current. So the major currents. So the major currents corresponds to Earth's atmospheric circulation. How the wind moves around the Earth. How wind moves in the atmosphere. Similarly, the currents will move. Right? The ocean current will move based on the atmospheric circulation. Air hege move agutte, current aage move agutte. Right? As simple as that. So okay, so at the middle latitudes, so the oceanic circulation at the middle latitudes, that is from 30 degree to 60 degree, it is anticyclonic. So this factor is actually a bit confusing, but you should just remember from 30 degree to 60 degree and both north and south, the oceanic currents are anticyclonic. That is in the clockwise direction. Anticyclone is clockwise, cyclone is anti-clockwise, right? But in the higher latitude, it is cyclonic. Higher latitude, that is above 60 degree, it is cyclonic. Above 60 degree, it is cyclonic. It must be in this direction. Okay, it's not important. So monsoon winds will also push the ocean currents. See, the monsoon winds, just like the water, just like how the air comes, monsoon clouds, it will push the water, ocean water also towards the west coast of India. Clear? Okay. Next you have heat is also transported. Just like along with the water, heat is also transported because of the ocean currents. Right? Ocean currents also transfer the heat. Next you have what are the effects of the ocean current? What are the effects? So, at the west coast you have cool waters. See, you have cool water in the west coast. See, cool water, west coast, cool water at the west coast. So, when there is cool water at the west coast, what happens? And also warm water at the high latitudes. So you will find the warm water. I told you, warm water at the high latitudes on the west coast. So I have discussed this concept already. So what will that do? It will lead to moderation. Moderation means what? So here on the land there will be some other temperature. Temperature will be either high or low. So whenever, see, California, here the temperature is very high. Because of cold current, the temperature will get moderated. Temperature will reduce, right? But here, see, Aguilar's current, here also temperature is very high. Because of Aguilar, see, here this area temperature is very high. Because of Benguela current, you have the temperature will get moderated. Temperature will reduce, right? On the other hand, you have this region is very cold. So because of North Atlantic drift, which is a warm current, this region there will be what? Moderation. That is reduction of temperature, right? So there will be reduction of temperature. So the temperature will neither become too hot nor become too low. If the temperature on the land is very high, the currents will bring it low. If it is very low, the currents will bring it high, make it high. So there will be a proper moderation. Moderation because of the oceanic currents. Also, it will lead to plankton growth. Plankton, it is, see, plankton means what? We call it a plant on the land. The same thing below the water is called plankton. So when both the ocean warm and ocean cold current, see, here this See, Gulf Stream and Labrador Current. Gulf Stream is warm current, Labrador Current is cold current. They are meeting here, right? So what happens when both types of water are meeting? There will be mix of lot of minerals. So because of which the plankton. So there will be no very less temperature nor very high temperature. So there will be moderate temperature, because of which there will be lot of plankton growth. So when the plankton growth is there, what happens? Lot of fish will go there to eat food. Plankton is a food for fish. So when they go there, what happens? They will get caught. So these are actually, here one place is there called Newfoundland. It is the world's biggest fishing place. So these fish go there to eat food, but people will catch them. Because here there is lot of fish because of the oceanic current. So ocean current will also help the economy. So let us discuss the major currents. These current names are very, very important. So we will move from north to south. See, whatever the dotted ones, they are Labrador current. We should know where the currents are flowing. So the Labrador current between Atlantic and the Canada, it is a cold current. North Atlantic drift, it is a warm current. It is a warm current. It is flowing towards the Norway, Finland, Sweden. It is flowing towards this direction. It is a hot current. And here you have the hot Alaska current. It is, see, whatever the current that moves upward, it is always hot. So Alaska current here next to Canada. California current, it is a cold current next to California. Gulf Stream, it is moving from equator, it is a hot current. Canaries current, it is a cold current. See, it is moving down towards the equator, it is always cold. From the equator towards the top, it is always hot, right? So it is from north, so it is a cold current, right? So then you have at the equator, you have north equatorial current and south equatorial current. They will always move from east to west. Why? Earth moves from west to east, currents move from east to west. So north equatorial current, south equatorial current. At the middle 0 degree, you have equatorial counter current, because see, two currents are moving on the above and below. In the middle, equatorial counter current will flow in the opposite direction. Clear? So this is it. Then here you have Kuroshio current moving from equator towards the Japan, and from the Alaskan region, from the Siberian region, you have Oyashio current coming from the north. And here you have the west wind drift in the near the Antarctica. West wind drift is a cold current. It is moving from west to east. So here you have south equator. Here you have the Humboldt current. Humboldt current next to South America, it's a cold current. You have Falkland current, it is also cold current. You have Brazilian current, it is a hot current. Brazilian current. Benguela current. Benguela current. So next to South Africa, Benguela current, it is a cold current. Whereas Agulhas current moves from the equator towards the north, towards the pole. So it is a hot current. See, I have remembered Benguela current and Agulhas. See, this remembering is very difficult. So what I have done is, see, it is moving towards south, it is around South Africa, right? So AB de Villiers belongs to South Africa. So this is AB. Agulhas current, Benguela current. Now you can remember, right? So Agulhas current, South Africa, Benguela current, South Africa, thanks to AB de Villiers. So it is Agulhas moving from equator towards poles, Benguela moving from pole towards the equator. Clear? Then you have the West Australian current towards the west, it is a cold current, and from here there is one East Australian current, it is moving. So this is all about the currents. Next, on tomorrow's class, we will discuss the life on earth, ecosystem and various things. How is the life formed on the earth? So food chain, food web, all these things. So tomorrow we will wind up the world physical geography and later take up the Indian physical geography. So once physical geography is done, then is human and social geography. That is very easy. That can be done very quickly. Only physical geography takes time, because here it includes lot of concepts. So any doubts, any feedback, comments, you put it in the comment section, or contact us on our Telegram channel, VHS Education Forum. right? Please make good use of the classes, both veterans and freshers. It's absolutely free, and you can also give feedback to us, and please take good care of your health. Jai Hind, Namaste.